Hello and welcome to our video notes for 4.3. Once again, we're going to start off by doing the warm-ups as part of our notes, so take a few moments, pause the video so that you can complete the warm-up for lesson 4.3. Alright, if you have finished the warm-up, go ahead and we will proceed with what we should have. Name all the sides and angles of triangle FGH. Well, you can see from this information everything we need to know to talk about the sides and angles. You don't even have to have the triangle drawn. FGH are the labels of the vertices of the triangle, so those are the angles. F, G, and H. The sides we get by taking each pair of consecutive vertices and making them the endpoints of a segment. So FG is the side, GH is the side, and FH is the side. This is how we should have written our answer. Number 2, what is true about angles K and L in this situation? Well, if we look at this, we know I is congruent to N, J is congruent to M, so we have two angles in one triangle congruent to two angles in another. We know that K must be congruent to L as well, and that was to be by the third angles theorem. Lastly, what does it mean for two segments to be congruent? By definition, that means the segments have the same length. Alright, let's take a look at lesson 4.3. The objectives today are to use properties of congruent triangles. So once we know that triangles are congruent, we can talk about their properties. And then we're also going to be proving that triangles are congruent by using the definition of congruence. So let's take a look. There's going to be a lot of information put out on these next few slides that are as part of the vocabulary and things you need to make sure you have written down in your notes. Hopefully most of it's already written down. If I'm going too fast, you can always pause the video to copy things down. These are the vocab terms we're going to cover, apart from the theorems and postulates: corresponding angles, corresponding sides, and congruent polygons. Alright, geometric figures are congruent if they are the same size and shape. Corresponding angles and corresponding sides are in the same position in polygons with an equal number of sides. So corresponding means in the same position. Two polygons are congruent if and only if their corresponding sides and angles are congruent. Thus, triangles that are the same size and shape are congruent. So we have this set of properties first. If two triangles, ABC and DEF, are congruent, we know the corresponding angles will also be congruent. So A is congruent to D, B to E, and C to F. And corresponding sides are also congruent. This is the definition of congruent triangles. The same could apply for quadrilaterals. We have four sides here. We have congruent angles, because these happen to be rectangles, so all of these corresponding right angles would be congruent. And the sides that correspond from one triangle to the other would also be congruent. We will mainly be focusing on congruent triangles in this chapter, though. Here's a helpful hint. Two vertices that are the endpoints of a side are called consecutive vertices. For example, P and Q are consecutive vertices in this situation. When we name a polygon, the vertices must be written in consecutive order. So you could name a polygon PQRS, or you could rename it QRSP, or SRQP, but you cannot say PRQS. You can't go back and forth. You need to follow the same order, either clockwise or counterclockwise. In a congruent statement, the order of the vertices indicates the parts that are corresponding. So when you write a statement such as triangle ABC is congruent to triangle DEF, you're also stating which parts are congruent. In this case, A and D would be congruent corresponding angles, B would be congruent to angle E, and C would be congruent to angle F. And then the sides, AB, those two letters together would match up to D and E, so we know side AB is congruent to side DE. And the same for BC and EF, and AC and DF. Those what we would get. So we're going to practice this in example 1. They give you a congruent statement. Triangle PQR is congruent to triangle STW. This statement tells us which pairs of corresponding parts are congruent. So this is what we should get. We have our angles. P is congruent to angle S, Q is congruent to angle T, and R is congruent to angle W. So we write our congruent angles in corresponding relationship like this. And we list our sides that are corresponding congruent sides. Side PQ goes with side ST, so those are congruent segments. because the triangles are congruent. Side QR corresponds to side TW. So QR is congruent to TW. And PR is congruent to SW. Alright, let's take a look at example 2a and 2b. On 2a and 2b, we're only going to do part of what the notes in your note packet ask you to do. Like on 2a, we're only going to find the value of x. We're not going to worry about finding the measure of angle f. We'll do the measure of an angle in 2b. So we're going to find the value of x in this situation. We have triangle ABC that is congruent to triangle DEF. Remember, corresponding parts are going to be congruent. Corresponding angles, A and D are the right angles. They also come first in your label, so you know they have to be together. B and E correspond, so they are congruent. C and F correspond, so they are congruent. And then the sides, AB and DE are congruent because the corresponding sides of congruent triangles are congruent. That's going to help us find x. We can set up an equation because we know AB equals DE, so we can write this equation. Why don't you pause the video and solve this equation for x, and then we'll check our answer. Alright, you should have had plenty of time there. If you need more time, pause at any moment, but otherwise we'll move forward. We're going to add 2 to both sides to get 2x equals 8. Then you divide by 2 on both sides to get that x equals 4. Let's look at 2b. In this case, like I said, we're going to eliminate part of this. So we are only going to be finding the measure of angle DBC. We're not going to worry about finding the value of x. We don't need that to do this problem. We want the measure of angle DBC. So this angle right here, we want to find that angle measure. Well, here's what we know. We have congruent triangles ABC and DBC. So their corresponding parts are congruent. The angle that corresponds to angle DBC would be ABC. These correspond. The angle that corresponds to angle A would be angle D. And remember that all 3 angles of a triangle, or all 3 angle measures within a triangle, should add up to 180 degrees. So we're going to put in what we know, that ABC plus 90, because we know these are perpendicular, plus 49.3 equals 180 by substitution. So we can find the measure of angle ABC by adding these two together and then subtracting 139.3 from both sides. So the measure of ABC is 40.7. We wanted the measure of angle DBC, but remember those are corresponding angles in congruent triangles. Since they are congruent then, their measures are equal, so the measure of DBC is also 40.7 degrees. Okay, now comes the part of the lesson that's a little bit more challenging. We're going to be working through example 3a and b, where we do a proof to prove that 2 triangles are congruent. And this is what we will spend most of the rest of our lessons doing, proving that triangles are congruent. Now, right now, this is what we need to know. If triangles are going to be congruent, then they have to have 3 pairs of congruent angles and 3 pairs of congruent sides. So from the given information, we are going to figure out several different things. Alright, like I said, from the given information, we know some different things here. AD bisects BE. Well, that means BC and CE have to be congruent. So I'm going to mark those on the diagram. And we're told that BE bisects AD, so these are congruent. Just because of what a segment bisector means. Those are definition of segment bisectors that tell us that. We know AB is congruent to DE because they're given that way. And we're also given that angle A is congruent to angle D. Now these extra markings I've put in come from another reason when we do our proof. But I want to show you what we have shown here. We have information that can show us 3 pairs of congruent sides already. We're given AB is congruent to DE. We can say that these are congruent by definition of segment bisector. So there's another pair. So I've already got 2 pairs of congruent sides. And then also, these are congruent by definition of segment bisector. So there's our 3 pairs of congruent sides. we have three pairs of congruent angles to talk about as well. We have angle A and D that are given as congruent, and we need to show two other pairs. Well, remember, vertical angles will be congruent. So there's another pair. And remember that if two angles of one triangle are congruent to two angles of another, then we can say that the third pair of angles are congruent by the third angles theorem. Once you've said three pairs of congruent angles and three pairs of congruent sides, you can finish your proof by saying the triangles are congruent by definition. All right? These are all things we're going to do in the proof, but wanted to give you guys a little bit of a heads up. Okay, so our proof statements will start off with this. We're going to start with one given at a time. We're going to start off with one pair of congruent angles. Those are given to you. And then we also want to talk about angle BCA and angle DCE because those are our vertical angles. So there's another pair of congruent angles. So if we go in order, our third pair of angles are congruent by the third angles theorem. So there's the three pairs of congruent angles. Now we need to show three pairs of congruent sides. So go back to that other given information. We are given angle or segment AB is congruent to DE, so there's one pair of congruent sides. And then we're told this. This is going to lead us to one more fact before we finish our proof. The definition of segment bisector then tells us BC is congruent to EC and AC is congruent to DC. There are the other two pairs of congruent sides. So we've shown 1, 2, 3 pairs of congruent angles and 1, 2, 3 pairs of congruent sides. So the triangles are congruent by definition of congruent angles, or triangles. Alright, in our last example in this proof, once again we are trying to prove that these two triangles, the one on the left, one on the right, are congruent. Here's what you're given. YWX and YWZ are right angles. We're given that YW bisects XYZ. That's an angle bisector, so we'll have congruent angles there. And W is the midpoint of XZ, so we'll have congruent segments there. You're also given that XY is congruent to YZ. So I want you to take a moment and mark the things that you think you know on this diagram. So here's what we should have marked. We have the right angles already marked there. Remember, all right angles are congruent, so there's a pair of congruent angles. We have YW bisects angle XYZ, so those are congruent angles by definition of angle bisector. We have W as the midpoint of XZ, so these are congruent segments by definition of a midpoint. And we have XY is given to us as congruent to YZ. So we just need to show that three pairs of angles are congruent and three pairs of sides are congruent. So let's work on our proof. We're going to start with one given at a time. We need to be able to break the proof up and show three pairs of congruent angles, three pairs of congruent sides. So we're going to start with the first given. Angle YWX and YWZ are right angles. This tells us that they're congruent by the right angle congruence theorem. So there's one pair of congruent angles. Then we're given YW bisects angle XYZ. That tells me those angles are congruent by definition of an angle bisector. W is the midpoint of XZ is given to us, so that tells me XW is congruent to ZW. Then something you're going to need to remember to use in proofs like this is that reflexive property. Notice that both triangles share side YW, so it's congruent to itself by the reflexive property, so we can have another pair of congruent sides. And angle X is congruent to angle Z by the third angles theorem. So we've shown 1, 2, 3 pairs of congruent angles, and we have 2 pairs of congruent sides. We need one more, and that is given to us. So angle XYW is congruent to ZYW by definition of congruent triangles. We've shown 3 pairs of congruent angles, 3 pairs of congruent sides. Your proofs are going to be a little bit longer here because you have to show in your proof 3 statements of congruent angles and 3 statements of congruent sides. We will begin the assignment in class.